Good afternoon, everyone. My name is Manish Chamdal, and I'm from BSIT2. I would be presenting the topic of logic formulation. So let's proceed. So these are the things we are going to talk about in this video. So first is logic formulation. Second is algorithm. Third, pseudocode. And lastly, flowchart. And afterwards, we're going to do a really simple problem for us to have a better understanding of the topic. So logic formulation is defined as a process of coming up with appropriate methodology in developing a specific program logic that will perform a prescribed computing task or solve a problem using the computer. So logic formulation in simple words is basically coming up with a solution or a method for a problem to be solved. Now these contain number of steps and a number of processes that we really need to follow for the problem to be solved correctly. So let's proceed. Um, so then we have algorithm. So algorithm is a process of solving mathematical problem using a number of steps. These are a set of instructions that defines the problem to be solved and how a problem should be solved. So basically, algorithm is just how the problem will be solved and what the problem really is. So for example, step 1, we need to start the program. Step 2, we need to initialize variables. Step 3, we compute. And step 4, we print out the results. So that's basically what algorithm is. And also, it also states that the problem that we will solve. For example, we have a problem that we need to find the sum of two numbers. That is basically it. Algorithm is just what the problem is and how we will solve it. So let's proceed to pseudocode. So pseudocode means false code. It is written in human readable language. It is not a programming language itself because it does not follow any syntax or symbols. Rather, it is a way to outline logic and steps of a program or algorithm before it can be implemented in a specific programming language. It is often used in developmental stages of a program for understanding purposes for the programmers. So pseudocode is not really a code. It's in the word itself. Pseudocode means false code. So it's not really meant for like computers. It's meant for humans because it's only a human readable language. And if we try to put pseudocode in a Java, let's say we will create a Java program and we created a pseudocode of a Java problem. So if we try to put it in an IDE, it will simply not work. Why? Because it's missing some syntax and symbols that is really needed for the computer to understand what we are trying to say or what we are trying to instruct it to do. So pseudocode is not really a way, or it's not really as a programming language. It's used in developmental stages for a programmer to have a better understanding of how he will input or how he will solve the problem. So it's a really good way, especially for large systems that requires more planning. And I think creating a pseudocode before coding it saves a lot of time and it also tells you how a program works. So let's proceed to flowchart. So flowchart is a visual representation of a program. It shows the flow of the program and shows various different processes a program goes through. This is an important step for software developers, especially when designing large systems, for them to have a better understanding of the code and used for documentation purposes. So flowchart is basically just visual representation of the code. So as I mentioned earlier, so when creating large systems, we really need to have, we really need to plan. And I think creating a flowchart and, a pseudocode is really helpful. It will save us a lot of time in creating programs. So now we will proceed to some basic flowchart elements. So first we have the terminal block. So terminal is basically a rounded rectangle, usually containing the word start or end. It signals the start or end of a process. And then we have input and output block. So this is a parallelogram used for taking input from the user or displaying the output. And then we have the processing. So these are rectangles. It is used for computation purposes. Example, sum is equal to num1 plus num2. So basically, we just use it for computation purposes. And then we have the decision block. So it is used in answering questions that have a condition like true or false, yes or no. It's mostly used in a program. So this type of block is mostly used in programs because some programs are based with decision prop. Let's say we need to make a certain decision for the program to proceed further. So, and then we have arrows. So arrows shows the flow of the direction of the program. These are arrows that interconnects every blocks. So, so now let's solve a really simple problem in the problem solving part. So question is make a flow chart, find the area of the circle, and also make a pseudocode. So we will be finding the area of the circle and making a flow chart and pseudocode. So the formula is A is equal to pi r squared. So we will be making a flow chart first. We will be going to shapes. We'll be selecting the terminal block. And inside the terminal block, we will state that the program has started. So afterwards, we're going to select the arrow and then select it downward. To show that the program is flowing downwards. And then we can use the initialization block, but sometimes it's not really important because always before we start a program, the value is always 0. We can use this block, but sometimes we don't really need it. So we're not going to be using the initialization block. But basically what initialization block is a block so that we can initialize that the value is equal to 0. But since the we are just creating, the value is always to 0. So we need to input the radius. So we will input the radius. For us to input, we will be selecting the parallelogram. So then we will be input radius. We will be inputting the radius. After inputting the radius, we will put another arrow. Then we will be using this one, the processing block. Let me just make it a little bit smaller. Uh, so now we will be processing it. So we will have to find the root. So for us to find the root, it's simply, let's name the variable as root. So if equal to radius times radius radius multiplied by radius, and the area, and to find the area we will be inputting the value of pi. So the value of pi is 3.14 sorry 14 multiplied by radius. So the root is equal to radius times radius, and area is equal to 3.14 times radius. So now we will be printing the area of the circle. For us to print, we will be using this block again. So let's place it here, and then also we will putting an arrow. So let's type the word print area. So it will print the area. And lastly, we need to stop the flowchart. We will be using the terminal block again. And of course the arrow. And we will be typing the word end. This is the simple flow chart. So we use the terminal block to start, and then we inputted the radius. So square root is equal to, we named it root. So the root is equal to radius multiplied by radius, and area is equal to 3.14 multiplied by radius. So then it will print the area, and the program will simply end. So now let's make the pseudocode. So pseudocode is basically just in words. We will be typing start. After start, we will input radius. We will be, so root is equal to radius multiplied by radius, and area equal to 3.40 multiplied by radius, and then we will print area and end. So pseudocode is just as simple as this. We only type, or we type the code into words. So this was the simple example of a flowchart and a pseudocode. Thank you for listening, everyone.